All right, welcome back. My name is Ngane Emmanuel and I am a software engineer, and I'm going to be taking you for this another video of the course building secure, scalable, low latency and fault tolerant application using Spring Boot and Java. Yeah. So in the last video, we talked about authentication as a system, right? Not just that it's login or tokens, and we walked through the full request lifecycle. Today we are starting our deep dive into the different stages, and we are going to be starting with filters, as in this image we are highlighting the filter section right here. All right. So why filters? So because filters are before your controllers, right? They are before your services and they are before your database, you know, and they can help you early on to catch requests and deny bad requests, right? So filters will decide whether a request is even deserved to be, exist in your system. If you secure the filter properly, then everything down the line becomes a little bit easier. If not, then it becomes very much harder to protect against vulnerabilities, right? So when the request enters your system and your Spring Boot at this stage, right, it has already passed the network layer, it has already passed the Tomcat, as we talked about in the different stages, but the Spring MVC has not yet, have not yet started. And so no controller, no mapping, no business logic has been done yet. And at this stage, your application is still very raw, okay? And this makes the perfect place to apply authentication because it is early, it is centralized, it is lightweight, and it is global, right? And in this stage, what can filters see in your request? And that's a question that you should really look at. And because that will allow you know what to check and know what you are doing here, right? So filters at this stage will look, your request will be able, they'll be able to see the headers in your request, the URLs, the HTTP methods, the IP address, the body if it is wrapped, cookies, and query parameters. But they will not be able to see controller info because again controller has not been loaded, DTOs again those have not been loaded, validated object those have not been loaded, and business context those have not been loaded. That is all being loaded by Spring. Alright, so filters basically work with raw HTTP data. And this is important because you get to understand that you're securing protocols at this stage, not the business logic. All right, because business logic is being secured in later stage. So let's look at the core security responsibilities for a filter as I have outlined in this diagram here. So the first one we're going to look at cores, and basically cores protect browser users from malicious website. So example, if a fake website tries to call your API using JavaScript, so without cores, the browser allows it, but with cores, the browser blocks it. It is important that you understand that cores does not stop hackers. It stops malicious websites using browsers, and so it protects the users rather than your servers. That is why it belongs to the filter. The second one is rate limiting. Rate limiting basically protects you from brute force attacks, bot attacks, credential stuffing, and basic denial of service attacks. Right. So, for example, an IP makes 500 requests per second, and that's suspicious, right? But if you have filters, then in your filters, if you have set up rate limiting well, you've implemented it well, the filter can count the request, can track the IP address, allowing you to block IP address of suspicious activities. It can use Redis or in-memory buckets, right, and block early. We are going to see how we're going to use in-memory bucket for the demos, but you should always remember to use Redis, especially when you're dealing with microservices. Let's move to the next. We have authentication. This is the most critical role, of course. In your filter, you need to extract the authorization header, validate the request using the parameters provided, and check other validation logic, right? So, for example, if you're using JWT for your security and your authentication mechanism, what you can do is you can extract authorization header, validate JWT signature, you can check expiration date, you can check if the token has been blacklisted, you can verify issuer, and you can pass claims, right? So if the token is invalid, request dies at this stage, it never reaches your controller, and this is where the identity is first enforced. So if this layer is weak, of course, everything else becomes really susceptible to attacks. And then the last one, or the number four, the fourth one we're going to be looking at is request sanitization and normalization. Okay. So filters can clean requests. For example, they can remove suspicious headers, right? They can normalize path. So for example, someone tries to use injection, you can first of all check against allowed path to make sure that the request does not go to the controller before checking, like we saw in our previous videos when we demo path injection. You can remove the entire logic and put them in filters, right? So they can reject malform, they can also reject malformed JSONs, they can enforce content types, again, to make sure that if your API just deals with images, someone does not send videos. If your API just deals with videos, someone does not send images. And they can also limit body size, right? So other validation checks can be, that are global, again, can be enforced here. So this protects against smuggling, injection attempts, and pass abuse. I think, yeah. So in this case, you are just looking at the overall idea of filters, right? Like they are custom officers. You think in the idea of custom, filters are like custom filters, right? They inspect everything before entry, and they make sure that everything meets the appropriate regulations that are defined by the system, right? So let's look at common attacks stopped at filter level, right? So the first one we talked about, brute force, right? So, and this is where attackers try thousands of passwords, right? And basically, if you implement filters plus rate limiting, right, they will help in stopping brute force attacks, right? And this rate limiting, we'll talk about rate limiting. You need to understand that there are different levels of rate limiting. For example, at the network level, you're going to have some kind of rate limiting, and at this level, you also have another rate limiting. But in the controller level, you can also have, like, if someone is trying to sign in, okay, the number of attempts that are wrong, that's another version of rate limiting. And basically, you are limiting the rate at which a particular action is being done. In this case, you are limiting the rate at which a request is being sent to the server, and this is where the rate limiting happens. And in earlier stages, you're limiting the rate at which a request or is passing through the network, is being sent to the network, right? And again, difference in levels, right? Rate limiting here, and somewhere in the controller or in the business logic, you enforce rate limiting, making sure that that request itself is being performed the appropriate number of times maximum. So we also have another attack, token we call token replay, right? And this again is in authentication, and this is when stolen tokens are reused many times, right? Again, if you implement proper validation techniques, for example, for JWT, you implement expiration and blacklist, then it will help to stop it. Another attack here is called header spoofing, and this is where attackers insert fake headers. For example, you can have a header like x-user-role, that is, and then they assign an admin role to it, and that itself it's a false header. So the filter, if you implement filters well only for allowed headers, the filter is definitely going to ignore that header and only trust the tokens, right, for validation. So another attack is malformed payload attacks, and in this case we have like broken JSON, huge payloads, strange encodings. Again, filters, if you implement validation checks here, filters will definitely pick that up and reject the request. Bot traffic rate limiting is going to stop bot traffic, and also IP tracking and blocks, right? So again, you want to look into all of these attacks, but again, at filters, basically we implement four main ones. This is course rate limiting, authentication, and request scope, right? Request parameters validation, right? So yeah, and then let's go. Yeah, and that's basically filters. And also, you have to understand the order of filters, and this is not just a random order, and this is in terms of order of computation, right? So basically, these are layers. So the first thing you want to check in your filters is a course, right? And basically, you're checking against cross-site request forgery, malicious JavaScript, and allowed headers and other parameters, right? The second thing, and you want to check, is the rate limiting. Now you're not yet doing authentication that's of the request itself using the tokens that are inserted in the authorization header or the username or password, whatever it is you're using. You are rate limiting, and essentially you want to determine if this is not an attempt by a hacker to brute force or perform a denial of service attack and other both requests, right? So you do rate limiting to make sure that just the appropriate number of requests are sent within the appropriate number of time, and they are mostly valid requests. And so cores are going to remove some of the bad requests. Rate limiting is going to take care of the rest. And then at this level, if a request pass, then now you have to authenticate the request, right? So you authenticate that request and make sure that the request, if you're using like a JWT, what you are checking for is that the token that is sent was generated by a trusted party, and in this case, let's say your server. And then, when if that comes out true, then you can trust the claims of that token, right? And at the last end, you want to validate the parameters itself, right? You want to make sure to look out for injection attacks and other malicious attacks. Um, and this is where you want to make sure that you do a lot of validation. And this is, again, this is a global validation. This is where you implement global security, and you have to understand that this security here protects against your entire API, right? Everything. If you have more fine-grained security, such as say authorization for different controllers, then you can use interceptors, right, and other validation techniques. So you can use annotations to provide a simple interface and use them. So for example, Spring has this annotation called add pre-authorize. If you have not known it yet, you can check it out. Basically, it is used on methods to force that method to authorize, to check for authorization before performing the method. And we're going to see something similar when we are looking at our own implementation. But again, it is very important to follow this order. So take note of it. We have course, rate limiting, authentication, and request scrubber. Right. So let's look at performance and security balance when it comes to implementing security in the filter stage, right? So since filter run every request, right, and they have to be fast, non-blocking, and lightweight, right? So in this particular section, you never want to call the database, right? So or do heavy computation, right, or call external APIs. So when you are running filters, you want to make sure that nothing is being delegated to maybe an external API, or you have to go to the database to retrieve a user, which is why a lot of people now are using JWT tokens or just tokens for validation, because they are stateless, right? If you use if you send just username and password, that's basic auth. How do you validate that? You have a single source of truth, which is your database. So it will require you to go to your database, retrieve the user, validate against the password, and then maybe, then before you populate the auth context, right? But if you're using stateless authenticators such as JWT, the token that is issued, right, you're just checking against the signature. You're checking the signature and the issuer, right? You can also check additional things such as the audience and the expiration date, which is very important, because when you're dealing in distributed systems and microservices, different APIs or different systems might issue different kind of token. So you want to check, usually for JWTs, you want to check mostly the signature. you want to check the audience, you want to check the expiration date, and the issuer. I think those are like the four main things that they check. And once you check that, you are not doing any database querying or external API. It basically does the processing on its own. That means when you check that and it is valid, then you can trust that particular claims, and you can now extract the claims and set the auth context, which you can obviously use within all this your application. And this definitely just set the authenticated user, right? So you want to make sure to avoid especially database computations here, because they are very heavy, right? So common mistakes here, again, we're looking at like you convert this to a lot of processing mini microservice, which is a bad idea. You don't want to use weak tokens here. You want to also skip. You don't want to skip validation here. So these are common mistakes. As you can see, they are all here in this picture. So if you are wondering where I'm taking all of this, it's right here, right? So you don't want to overload logic. You want to keep it simple and straight to the point, and you don't want silent failures, right? So you don't want to catch exception and something like catching exception and then you continue, right? Is that the idea is that once it fails, you stop and you return on it. You end the processing there, you end the request there. The request does not move to the next stage. That's what the authentication at this level does. It basically just says, all right, you need to pass all these checks. If you lack even this tiny bit, I don't care whatever it is you have, you are not allowed to access this particular server or this particular service, right? So it is non-compromising, right? So certain security design principles you should consider when implementing filters. It should be so the first one is that you should fail fast, right? So if something looks wrong, block it. No log, and continue, right? No maybe, just block. If something looks wrong, block it. Fail fast is very important, right? And also, again, we'll talk about how they fit into security in depth, right? So they are like gatekeepers, right? And again, so they are like one stage of the entire security pipeline, and they are the global stage, right? So they protect against all this other security. Remember, most here you are doing different validations, but here, once it's passed here, basically you're telling all the systems like, you know what, trust this request to this particular level because the checks here they have passed here. So I'm not revalidating everything here. I'm not checking the tokens again here. No, right? Right here, maybe at the interceptor level, I'm only looking at what the authorization and the controller level. Then the service level, I'm looking at business logic validation, different business logic validation. Same in database. So you want to make sure that this particular layer is very important. It's very well implemented. Sorry, right? So that's it. So let's conclude this. So you have to remember that filters are not just middlewares, right? They are first security boundaries inside the application. Right? They protect your CPU, your memory, your database, your users, and again your reputation. Strong filters will equal strong resilient system. Weak filters will equals permanent firefighting, right? So you'll be fixing bugs every time. So in the next video, we'll implement a custom rate limiting filter, right? Basically, it's going to be a JWT authentication filter and a proper filter ordering, right? So we're going to see course, we're going to see rate limiting, we're going to simulate this one, right? But we're also going to see course, right? We're also going to simulate this one, and we're going to see authentication with JWT, right? So we're going to do this step by step, right? So if you want to build a system, right, that scales securely, right, continue to follow this channel, continue to follow this video, and let's, talk about security, authentication, fault tolerance, scalability, and low latency. My name is Ngane Emmanuel. Once again, I have been your instructor for this particular lesson and this particular session. And subscribe to my channel, click the notification bell. Also follow me on my social medias. My link are in the description below, and also the link to the repository where you find all of these in the description below. Right. Thank you very much for watching to the end, and I hope you found this useful. Till next time, have a nice day. Bye.